Hey everyone, I am going to try to give you a quick review of the periodic table and elements so you can be ready to take the test on Thursday. I hope so. Are you ready? Okay, here it comes. First of all, you got to remember that this thing right here, these are the atoms we're talking about, okay? These are atoms. Now, you will probably find, for example, the following. You might find a question that suggests P equals 10, like it says right here, P equals 10. And you're saying, what does that mean? Got to remember, in any given atom, you've got the nucleus. You've got in that nucleus protons, neutrons. Then circling around the nucleus are the energy levels and the electrons, right? Okay, so if you get a P equals 10, you know what that's telling you? It's telling you that there are 10 protons. You know what that's also telling you? Well, there is a certain number on the periodic table, and let me see if I can get you a periodic table here. Certain number on the periodic table. You got that periodic table right there, okay? Is that a good looking periodic table? Yeah, it's a good looking periodic table. Right there's a periodic table. And there are certain numbers starting off on the left hand side, 1, going all the way to number 2 on the other side, which is 1 is hydrogen, the other side is helium. Now, that 1, that 2, and the other numbers are the atomic number. That's what you see at the top of every box. And every box has an element. Okay? So you got the box with a number. That number is the atomic number, which is the number of protons in that atom. The number of protons equals number of electrons. We getting it? Okay. Now you say, man, you go fast. That's why it's this video. And you can stop it and replay it. Anyway, so you got that, right? So you got the atomic number. Now there's something else you got to know about that periodic table. That periodic table is divided up, okay? You got what are called groups and families. Groups and families. The groups and families have similar properties. The groups start off on the left-hand side right here. And the left-hand side is going to be I think it's the alkaline metals. I believe that's correct. Then the next group right here is the alkaline earth metals. Then you have the metals. And then you have the metalloids and a few of the nonmetals and the gases. Over here on the right-hand side, the group 18, is going to be the noble gases. Running out of breath? So am I. But anyway, let's keep going. Then you have something called the periods. Where are we at here? 1, 2, 3, 4, 5, 6, 7 periods. What is the periods? Those represent the energy levels. Remember what I told you about an atom? You got the atom right here. You got that nucleus. And then you got those things circling around the nucleus, those electrons. Well, those electrons fly around in energy levels. And we went back to the periodic table. We saw the periods, right? Those periods that go this way to this way. 1, 2, 3, 4, 5, 7, 6, 7. Those periods represent the energy levels. All right. Are you with me still? Oh, come on. I know you are. I can see you smiling. Or is that a shadow? Anyway, here we go. Then you have something else. And this is important. You have the qualities. I'm going to give you some of the qualities of the metals. Listen carefully. This is the quality of metal. You got shiny, high melting point, mostly silver or gray in color, mostly solids at room temperature, except of course mercury, which is a little bit obstinate, and that's liquid at room temperature. But anyway, then you got malleable, which means you can hammer it out. And then there's ductile, which is able to be drawn into what do they call those things? Wire. And then you've got the good conductor of heat and electricity. Yay! Okay. Now we got nonmetals. What are they? Well, you know what they are. They're the ones that aren't the metals. Ha ha ha. Anyway, You get the dull. Nonmetals are dull. I mean dull. They are low melting point, brittle, break easily, non-malleable. In other words, you can't beat them up and they take a hammer to them. And not ductile, can't those guys that have a little bit of everything. They're right there in the squiggly line between the gas and the metals. They're called the metalloids, and their qualities include found on the zigzag line of the periodic table, have properties of both metals and non-metals, can be shiny or dull, and are semiconductors. Sometimes they conduct, sometimes they don't. Boy, we're working our heart out, aren't we? We'll keep going. We'll keep going. Trying to get this done as quick as I can for you, okay? All right. So, what's next? Well, you got a couple questions. For example, on one it says, if I have the name of the subatomic particle and the name is a electron, then locations where? The electron is located outside the nucleus. Then you have the electrical charge of an electron is a negative charge. And then you have the relative mass is 1,287 or whatever. The electron is the smallest particle. Then you have the neutron, which is inside the nucleus, and it is neutral, and it is 1 AMU, 1 atomic mass unit. Then you have the proton inside the nucleus. Its electrical charge positive, and it is also 1 AMU, 1 atomic mass unit. All right, we're almost done, folks. Just hang on tight. So what do we got here? We got to go back now and check out this one. There's a couple questions here that I think you might want to know about. Let me give you an example. You have here an example of, it says here, let's say you have to have an element that's in the group 14, period 2. What do? You look right here. You look at group 14, which is going to be, let's see where the group 14 is. Group 14, which is going to be around here. Not seeing it too quickly. Right around here. And it's down to 2. I'm going to say if it's 1, 2, group 14, you know what? This one's not labeled. I think this one is. No one ain't. Anyway, close. Let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Anyway, it's in this area, right around here, 14. You drop 2, and there you got the, you find your elements. If you got a periodic table that's numbered, you can find it easily. Just go count to 14, find the 14, and then go down 2, and there's your element. How about this one? It says group 2, period 2. Same thing. Look at the groups. 1, 2. Go down 1, 2, 1, 2, and there you got your element. Now, what do you find in your element? Watch what you find with your element. Are we all getting exhausted yet? I'm almost done. I'm almost done. Here we go. What do you find with your element? You find the atomic number. You find the symbol for the element. You find the name of the element and the mass number. Now remember, the atomic number equals protons. The mass number is the protons and the neutrons put together. Are we there yet? Oh, I'm joking, okay? So that's what they call 8-man. Let's look what 8-man says. Atomic, oops, where's 8-man at? Pardon me, let's look for 8-man real quick. That's the phrase they use in this thing. See if I can find it for you real quick here. I can find it, I'm sure, if I look hard enough. I'm almost there. Where's 8-man at? Well, where is 8-man? Where is 8-man? It's here somewhere. Oh, there it is. Atomic number, A, equals protons, P, equals electrons, APE. Then you got mass number minus atomic number equals neutrons. Mass number minus atomic number equals neutrons. That's man. All right? So anyway, I know a lot of information crammed into all of it. Well, let me give you one last thing here real quick. Oh, I don't want to forget the valence electron. You got to understand, folks, every energy level has a limit as to how many electrons can be in it. 2 for the first one, 8 for the other next one, And I don't know what the other number is for the next one. But anyway, if you have a certain number of electrons on the outer shell, and let's say there's about 4 and there should be 8, then there's a little bit of reactivity there because it has a charge to it. Remember, valence electrons are on the outer shell and help with reactivity. If you don't have a full shell, then you don't have a if you have a full shell, you have a less reactive shell. If you have a full shell, you have a stable shell. If you have a less than full shell, it's open to be reactive. I understand what I'm saying? Oh, please understand. Anyway, there, I think you got it. I know I packed a whop in there. I tell you, I whopped it so hard, I whacked it so hard, I packed a whole bunch of snowballs in there. But I think you'll get it. Just if you need to play this again, just remember one thing. At least I didn't sing a song. Good luck on that test. I wish you the best. If you have any questions, let me know. Later. Bye.